So Nick, we're coming back to what you were talking about earlier. Lines, grades, and segments. Lunch bell, I'll wait for it.
Much better.
Okay, so we talk about lines, right? What do we know about lines, just in general? They're straight, good. They go on forever, so they're infinite. And so they're straight, they're infinite, and so we represent that with two arrows. Does it have a starting point? Does it have an ending point? Okay. So it's just as simply infinite. Which takes us back to lines of latitude. Do they have a starting point? Do they have an ending point? No, they just keep circling around. Interesting. Array. What's special about array? What makes it different? It starts and then keeps going. So it has a single endpoint, and then it just keeps going out to infinity. Kelsey, I liked your picture of array. I thought it was perfect. It was a measure tape, where the casing on the tape measure was the endpoint, and then the tape measure just kept going out. It's a perfect example of array. And so we can label that. I'm going to call that point A and point B. This is where we have a difference. When we label rays, we label them with an endpoint first. And now notice, how is that symbol that we just put up there, how is that different from a line symbol? No, but look at the symbol right here. Yeah, it only has one arrow. So that's the ray. So ray AB is completely different. We'll put on here, is not the same as ray BA. Okay. Why? Why are they not the same? That's it.
They don't have the same starting.
Yeah, they don't have the same starting point. That's it. Ray AB, it tells you it's all about direction. Ray AB tells you go from point A and go out infinitely toward point B. On the other hand, ray BA tells you to start at B and go infinite toward A. So they are not going to be the same. Then we have segments. A segment is really, imagine that I literally cut my line at 2 points. That's your segment. It's just a portion of the line. And so we can have segment AB. And we represent segments with just a single line. We'll call that segment AB. Is segment AB the same as segment BA? Look at the figure. Is segment AB the same as segment BA?
Yes.
Yeah, same exact shape. So the only time we have to be really careful about saying which way we're going is with the rays. That's the only time we really got to be careful with that. Any questions so far on what we've covered? On labeling, basic geometric definitions. It's a lot of boring stuff, I know. We've got to make sure we cover this. So let's do this. Work with your partner. I want you guys to name, or I want you to complete these 3 questions. Brian, I want you to go plot point P up there on the board. So I need a plot and label. Should we label it? Hit the, see where it says menu right there on the little board? Hit the top arrow. Very good. Hey, Chris, I want you to label or plot and label point Q. That's fine. That's good. Caitlin, I need you to plot point R. Taylor, I need you to, Taylor Smith, I need you to plot point S. All right, Mackenzie, what 3 points are collinear?
I can't figure that out.
Okay, remember, what does it mean to be collinear?
Should be on the same plane.
No,
No. It's in line.
they have to be on the same line. Which of those 3 points look like they're on the same line?
R, P, and Q.
R, P, and Q. Very good. By the way, how do you guys know if 3 points are collinear? If you had them plotted out like this, how could you definitely know for sure they're on the same line? Not really. John? No? Up and down, we're good. Nick? Yeah. If they're on the same line, what should be true about their slope? Should be the same. So if I look at my slope from R, P, and I went over 1, 2, and up 1, 2, 3, that's the slope of 3 halves. And if I do it again from P to Q, over to up 3 again, I get the same slope. So they are definitely collinear. All right, and Jake, what about number 3? 2 intersecting planes. Let's change up the lines. Might be a little more easier to answer that. 2 intersecting lines. So RS, so line RS, right? We want to make sure we use the correct notation. So line RS, and give me another line that would intersect RS. Well, okay, so here's line RS, right? Going through like that. There's line RS. What line intersects that? Yeah. Right? Because if I draw a QS, we intersect at S. Okay. And S is, what would you call S? Point of Concurrency, okay, so to be concurrent needs to be at the same place. Okay, any question on those three questions?